Hornets, and welcome. Today we are working on integration by limits using the integration process. And this is number 3 of my installments using cubics. So you should have already seen the one for linears and quadratics. And if you haven't, I recommend that you take a look at those first so that this will make more sense. After all, I am not going to go through all of the details that I've covered on the previous videos as it does build and is cumulative. Be aware that cubics are a little bit more difficult and require a little bit more work. They are, unfortunately, a little bit more structured, and therefore we have less malleability with them. However, there are certain areas that we are still able to simplify quickly, and those include our limits as n approaches infinity for all of our values of n less than the highest power. Okay, so please be aware of that. Now, I am going to only be doing numbers 2 and 4 in this worksheet. And for those of you who are not students of mine, I recommend you take a screenshot now. Excellent. All right. So let's go ahead and begin. We're going to start with number 2. And you'll notice I've already taken the opportunity to write this down for you. A couple of things that I would put up at the top. Let's just remind ourselves that delta x is going to be b minus a divided by n. C sub I, also known as x sub I, or the x that we will be working with, is going to be our first term, time plus the delta x times I. And then we're going to be putting it into the form of the limit as n approaches infinity for delta x times the summation as I goes from 1 to n of f of c sub I. We're going to be doing each piece one at a time. And once we get to that limit form, that's where we're going to take off. All right? So here we go. First of all, delta x is the gap between 1 and 6. 6 minus 1 is 5, and this gives me 5 over n. Our c sub I, or x sub I, the x that we are going to be working with, is therefore going to be our first value a, which is 1, plus 5i over n. As we construct, we're now looking at the limit as n is approaching infinity. We have our delta x, which is 5 over n. We are putting into our summation, I equaling 1 to n. And we now have to put in our c sub I. So this is giving me 5i over n plus 1, the quantity cubed, minus 5i over n plus 1 to the first. Now you'll notice I've written it with the I first, followed by the constant. This is so that when we finish, we will have standard form. We're now going to have to work with the foiling, a plus b, the quantity cubed, and this is going to give me a cubed plus 3a squared b plus 3ab squared plus b cubed. Once we have this, we're going to be distributing the negative into the 5i over n plus 1, and we will then add like terms. We should end up with something that has 3 terms in it at the end that we can then work with. Here we go. So we're going to start with I cubed, the first term cubed. This is 125 I cubed over n cubed plus 3 times 5 times 5, which is 75 I squared over n squared, plus 3 times 5 times 1 squared is 15I over n plus 1. We then have a minus 5I over n and a minus 1, and the constants cancel. That means that we now have the limit as n is approaching infinity for 5 over n times the summation as I starts from 1 to n, and we're now looking at 125I cubed over n cubed plus 75I squared over n squared. Now, before you do the next term, make sure you simplify so that you have 10I over n. This is now what we will be able to work with and substitute our various parts with. So we have the limit as n approaches infinity, and I'm now looking at 5 over n times 125 over n cubed times the summation of I cubed. I goes from 1 to n, plus the limit as n approaches infinity for 5 over n times 75 over n squared times the summation of I squared as I moves from 1 to n. Last term, plus the limit as n approaches infinity for 5 over n times 10 over n times the summation of I as I moves from 1 to n. Now, as we've stated in previous problems, because I'm working with an I cubed, and we know that I cubed, let's just write this down off to the side, is n squared times n plus 1 squared over 4. Every term under n squared over 4 is going to go to 0, which means we don't have to write it. And if we do this, it is because you want to and you want to do more work. I don't want to. So I'm going to replace this piece here, the summation of I going from 1 to n for I cubed, with only the highest power. That is n to the 4th over 4. We're then going to multiply, and as we do, our 125 times 5 is 625, and I have n to the 4th down in the bottom for the limit as n approaches infinity. I then am going to the next piece. 75 times the 5. I'm ignoring you. I hope that's a jet, not a lot of thunder. If it's a lot of thunder, we have a lot of thunder in California today. I think it's a jet, though. It's awfully loud and awfully low. And where is your 5 over n? There we go. Summation. Now we're going to replace this piece, and we're replacing this piece, if you recall, by n cubed over 3. Plus the limit as n approaches infinity, 5, and this is now 50 over n squared, and I'm now replacing my summation with n squared over 2. There we go. Times n squared over 2. Powers of 4 cancel, powers of 3 cancel, powers of 2 cancel. I have 625 over 4 plus 375 over 3 plus 50 divided by 2. This gives me 156 and 1/4. This is giving me 125, and I am then adding 25. When I finish, I am left with 306 and 1/4. This is my answer. We're now going to check our work by going back to the original problem, putting it into our calculator, and seeing what we get. Math 9, from 1 up to 6, and now we're putting in our x cubed minus x dx, and we should get 106.25. Ta-da! Pardon, 306.25. And it's the answer. All right, let's go ahead and take a look at number 4 now. And if you recall, number 4, for those of you who took the screenshot, is the integration from 0 to 3 of 2x cubed minus x squared plus 5 dx. Now, these problems are always easier when we start at 0 because we're not going to end up with a binomial like we did last time. Remember, if we start at a value other than 0, we're going to end up having a binomial for our x sub I. And when we put it in, it's going to mean a lot more work. Because we don't have to worry about that, it's going to be a lot simpler. Our delta x is simply 3 over n. Our c sub I, or x sub I, equaling the x that we're working with, is going to end up being 0 plus 3i over n, which is just 3i over n. Notice, we no longer have a binomial, and we are freed from that distribution process. So now we're going to go ahead and put it together as the limit. As n approaches infinity, for 3 over n times the summation as I starts at 1 and goes up to n. 2 times 3i over n, the quantity cubed, minus 3i over n, the quantity squared, plus 5. Once again, very little to do here, not much to worry about. We do have to get the 27. We then have to multiply it by 2 in order for us to get our 54. We are going to have a 9 over the n squared, etc. So it's not that bad. Limit as n approaches infinity. Here we go. 3 over n. I is starting from 1 to n. And I'm now looking at that 27 times 2 is 54, I cubed over n cubed, minus 9 I squared over n squared, plus 5. We're now going to distribute this piece to each term, and then we will continue. The limit as n approaches infinity for 3 over n. I'm going to pull out the 54 over n cubed, leaving me with just the I cubed. Then I have a minus. The limit as n is approaching infinity, 3 over n, times 9 over n squared, times the summation of I squared as I goes from 1 to n. And then we have plus 5. And let's make sure that that plus 5 has my terms in front of it. The limit as n approaches infinity, 3 over n, times the summation of 5. Alrighty, this piece right here is being substituted by n to the 4th over 4. This piece is being substituted by n squared over n, and this piece is just being substituted by 5n. Here we go. The limit as n is approaching infinity. Now you'll notice I am going to want to multiply this out, and 3 times 54 is 162. It is over n to the 4th times n to the 4th over 4 minus the limit as n approaches infinity. I have 27 over n cubed multiplied by the n cubed over 3, n cubed over 3 for the quadratic. Let's make sure I have that correct. And then we have plus the limit as n approaches infinity for 3 over n times 5n. And I do apologize for misspeaking on that sum. We're now going to have to simplify this. So we're looking at 162 after the fourths cancel and the cubes cancel and the n cancels. And this is giving me 40 and a half, or 40.5. I'm subtracting 9, and I'm adding 15. And therefore, I'm ultimately getting 46 and 1/2. We're now going to check our answer by going back to the original, hitting Math 9, putting in my original. We're going from 0 up to 3, and inside of the parenthesis, I have my 2x cubed minus x squared, and then I have plus 5. Now, if you've been watching, you'll notice that there are a lot of little places to make mistakes, and we hopefully can avoid them. We get the correct answer is 46.5, and that checks our work. That was worksheet number 3 for the integration process by limits. Number 3, working with cubics. I hope this has helped. If it has, please remember to click like so that I know that this is a reasonable video for you to work with. Thank you very much. Please be safe, take care. I hope you stay dry, and I hope everything goes well with you. Take care. Bye-bye, Hornets.